Kia ora year 11 and 12. Here is question 1 from the level 2 algebra paper in 2014. I've put all of the question into one video, so it starts off at achieved level and goes up to excellence level. As usual, you'll get more out of this if you have a go at the questions before you watch me going through the answers. So I suggest you grab your maths book and a pen and work through it with me. Alright, so there's a pretty heavy emphasis, as you know from class, on simplifying. So the first simplifying question, this is an achieved one, we've got 5 over 8 to the power of 4 to the negative 3. So when I see that negative sign, negative exponent, that tells me to take the reciprocal of what's inside. So it's 8 to the power of 4 over 5 to the power of 3, which is equal to a to the power of 12 over 125. Right, remember that when I've got a variable here, I multiply my powers. When I've got a number down here to the power, I do the powering. I do 5 to the power of 3. So that's a little achieved question. Nice warm-up. Okay, another simplifying one, 0.25 x cubed to the power of 1/2. So again, I do the powers when it's a number. So that looks ugly, very ugly to me, but I'll come back to that. Times x to the power of 3 over 2. Right, so it's easier to think of this as a square root sign for me, and 1/4 times x to the power of 3 over 2. The square root of 1/4 is 1/2. So it's 1/2 x to the power of 3 over 2. And before anyone asks me in class, it's totally fine to write that as 0.5 x to the power of 3 over 2. Okay, both of those are fine. So another achieved tick. So a little U code. Right, the next one, more simplifying, getting a little bit more complicated. 8x to the power of 6 to the power of, oh, very hard to read that, but it's 1/3 over 3x to the power of negative 2 to the power of 4. So it's 8 to the power of 1/3 times x squared, right, multiplying those powers, over 3x to the negative 8. Now, what is this 8 to the power of 1/3? Well, that's just the cube root of 8. So this equals 2x squared over 3. The x to the negative 8 means that it's x to the positive 8 in the numerator. Okay, and so that equals, my final answer is 2/3 x to the power of 10, which, just in case anyone's labouring under year 9 confusion about fractions, is exactly the same as that thing there. Okay, so it's 2/3 of x to the power of 10, which you can also write as 2x to the power of 10 divided by 3. So that is actually a merit question, believe it or not. So you'd be pretty happy if you got a merit tick for that, I think, because it's really nothing different from the easy first two. It's just applying your power rules and simplifying. Okay, on to something a little more interesting. 1 root of the equation x squared plus mx plus 12 equals 0 is 3 times the other. Find the values of m. Now there are two ways you can attack this question. We've got a quadratic, and we're told one of the roots is 3 times the other. So the first thing we should do is define a variable. So we're going to say let the first root be n, and then let the second root, well, it's 3 times the other one, so it will be 3n. Now, when you're looking at that, you often get quite comfortable with using the quadratic formula to solve problems. So you might decide to do something like this. I'm going to show you this. This is a big rabbit hole that you don't want to go down, but just in case any of you tried it. We know that the first root is n, so we're going to have the two roots of a quadratic are always given by this thing here. And we've learned quite a lot about this. We know that this discriminant is important, and it's going to tell us if we have 0, 1 or 2 roots. So we know all of that. So it's tempting to try and use the quadratic formula, and we will get x equals, well, A is 1, B is m, C is 12. So off we go, we put things in, and we get negative m plus or minus m squared minus 48 over 2. And then we can solve that for n and 3n. Now, if you proceed down that path, you'll quickly get yourself into a mess. So there must be an easier way. And there's a much easier way, and it's using the fact that we've got the two roots of the equation. So that means we can write this expanded form in factorised form. So we're going to do that on the next slide. Okay, so we know the roots are n and 3n, which means that my equation can be written in this form. So this is already looking like a pretty easy problem now. We just need to expand and match up our coefficients. Now there's another video that I've done on this called Miscellaneous Quadratic Problems. So if you want to see a couple more examples of this technique, go and look at that. So x squared minus nx minus 3nx plus 3n squared equals 0. Right, so we've got x squared minus 4nx plus 3n squared equals 0. But we know that our original equation was x squared plus mx plus 12 equals 0. So we're matching up the coefficients. So we have 12 equals 3n squared, n squared equals 4. Right, now there are two solutions to n squared equals 4. So we've got n equals 2 or n equals negative 2. Right, watch out not to lose the negative 1. So we're going to use that. We're going to take each of those situations and we're going to substitute them back into our factorised form and then expand again. So on to the next slide to do that. So if n equals 2, we have x minus n, x minus 3n equals 0. So x minus 2, x minus 6 equals 0. X squared minus 8x plus 12 equals 0. In which case, so we're looking for the pattern, x squared plus mx plus 12 equals 0. So m in this equation equals negative 8. So that's the first one. Next one, if n equals negative 2, x minus negative 2, x minus negative 6 equals 0. So x plus 2, x plus 6 equals 0. Fine to go straight to that line of working, by the way. So x squared plus 8x plus 12 equals 0. M equals positive 8. Okay, there's 8 there. I'm looking for the coefficient there. So there are two solutions there. Just one thing, it's really going to make things better if you start by defining your variables well. So you want to be carefully saying, let the roots be. Okay, and with any of these more difficult algebra problems, defining your variables correctly at the start will often get you going on the right path. Okay, we've got two more excellence questions to do, and they're both quadratic ones. Right, the next one is a discriminant problem. The equation 3x squared minus nx plus 5 equals 0 has two distinct roots. So two roots means b squared minus 4ac is greater than 0, strictly greater than 0. Here a equals 3, b equals negative n, c equals 5. So b squared minus 4ac is equal to n squared, I'll do it properly, negative n all squared, minus 4 times 3 times 5. So we need n squared minus 60, strictly greater than 0, either, so we have n squared is greater than 60, either n is greater than root 60 or n is less than negative root 60. Right, if you're not sure about that, think about your number line. For values above root 60, you'll get positive 60. But on the other side, for your values below negative root 60, you'll get positive values as well. Okay, so n greater than root 60. Let's quickly have a look at what the square root of 60 is on a calculator. But actually, it's better. I think it's better to leave that as a surd because it's an irrational number. But an approximation, which is obviously accepted because it's in the schedule, is n is greater than 7.7 or n is less than negative 7.7, and that's to 1 dp. Again, I would probably have rounded that to 2 decimal places, not to 1, but obviously it was fine in this particular marking schedule to go to 1 dp. It looks a little bit too rounded to me. Okay, next question. Right, last question. Solve this equation here, 10x to the power of 4 minus 13x squared plus 4 equals 0. Now, we've done some of these in class. In level 2, the only real kind of equation you can solve is a linear one or a quadratic one. So there must be a way to turn this equation into an obvious quadratic. And there is. So let's use our defining the variables trick. Let u equals x squared. Then we've got 10u squared minus 13u plus 4 equals 0. So we've turned this yucky thing with x to the power of 4 into a pretty simple achieve level year 12 quadratic. So we need to try and factorise that, or you could do it on your calculator. I know some of you will, but let's just take a look because it turns out it factorises pretty easily. The first thing I see here is I've got a minus here and a plus there, so I put down my 2 minus signs. I've only got a few different combos that will give me 4, 1 and 4, 4 and 1, and 2 and 2. So it can't be that bad. Let's try 5u here and u here. So I'm looking at that and I'm looking for a combo that's going to give me minus 13 in here and 4 in here. So I might try, well, I've made a mistake there, haven't I? 5u times u will not give me 10u squared. 5u times 2u. Right, that's better. We'll try putting down a 1 here and a 4 here. Does that work? No, that's minus 2u minus 20. So that's wrong. So get rid of that. But let's have a look at the other way around. 5u minus 4 and 2u minus 1. Will that work? Yes, it will, because I've got minus 8u and then minus 5 more u. So that's good. We've got our factorised form. So either 5u minus 4 equals 0 or 2u minus 1 equals 0. U is equal to 4/5 or u is equal to 1/2. Now if you got that far, you're up to merit already, but actually we've done all the hard work. We just have to keep on going and get right back to x. So u is equal to x squared. So on the next slide we'll work back to x. So u is equal to x squared. So 4/5 is equal to x squared. X is equal to square root of 4/5, or the negative root of 4/5, which is 2 on root 5, or negative 2 on root 5. So that's from the first u solution. Or we had u equals 1/2. So x squared equals 1/2, x equals 1 over root 2, or x equals negative 1 over root 2. Right, and that's another excellence question. So I've put the schedule in next so you can have a look at how you would have gone. Alright, so here's the schedule for 2014 question 1. Just try and make that a bit bigger. You all know you can get these from the NZQA website or through the Onslow. If you go to our Moodle page, there's a link there to the papers and schedules as well. But just notice that you had 3 opportunities in there to get excellence. Those last 3 questions all would give you an excellence tick. And if you've got one of those all the way through to the end, you get yourself an E7 for the question. If you get 2, you get an E8. Alright, so once you get the hang of those quadratic ones, you should be able to get most of the excellence questions that pop up like this. Thanks for watching. Let me know if there's anything you want me to do differently with these exam paper videos. I'll do them, huh?